Focusing on a KB for a healthcare service, in previous videos, we analyzed how to insert, update, and delete through the business component of a two-level transaction. In those videos, starting from the two-level office visit transaction, which had a series of declared rules, in particular, some error rules, what we tested was to insert an office visit with a patient, update an office visit, changing the office and modifying a line, deleting one and adding another, and deleting an office visit through a business component variable. Now we want to assign in batch mode the office visits for a given physician in the week following a given date in his or her preferred office. For example, for Dr. 1, Office 1, we'll want this office visit scheduled Monday, Wednesday, and Friday in the shift chosen for those days. For example, 1, Tuesdays and Thursdays on the next shift, 2, and Tuesdays and Thursdays in the remaining shift, shift 3. Basically, we'll only want to assign the office visits without patients. That is to say, only the records corresponding to the 7 headers of the transaction, meaning that we'll work on the office visit table and complying with all the checks and rules of the transaction, so we'll do it with a business component. For example, using a single variable, filling in the required data for the first record, and applying the insert method to it, then clearing it and doing the same for the following office visit on Wednesday. That is, loading the data and applying insert, and so on. We clear, load the data for Friday, shift 1, insert, we clear, load data for Tuesday, shift 2, insert, we clear, load data for Thursday, shift 2, insert, we clear, load data for Tuesday, shift 3, insert, we clear, load data for Thursday, shift 3, insert. Here we implement the requirement with a web panel where we ask the user for the data. Here, we'll show the resulting message collection. And in the event, we first clear the message collection that would have been shown in a previous execution. Call this proc that returns for this date the date of the following Monday. And instead of asking 7 times for memory for the variable, assigning the corresponding elements for each one, and doing insert, we choose to use the repetitive structure for to write the insertion only once for Monday, Wednesday, and Friday, where only the day changes and everything else is kept. Then another one for Tuesday and Thursday, which is the following shift, calculated with this proc. And here we assign it. And then another 4, also for Tuesday and Thursday, but in the remaining shift. Note that in addition to improving the code, in short, what we're doing is using a BC variable, assigning it the header values, and using the insert method to try to insert in the corresponding table. Then we process the messages obtained. Let's try this when there are no office visits yet in the table. Of course, if we enter non-existent foreign key values, for example, a non-existent doctor, the insertion attempts will all fail. The insertion will be attempted by doing the same checks as through the transaction. Now let's see the successful path. Another way to program this would be to load each BC into an item in a collection, and then give the insert order to the entire collection. we know that internally each item will be accessed and an insert of that item will be attempted. That is to say, we would define an office visits variable, collection of the office visit BC, and we would load the information in the office visit variable. But instead of already inserting in the database, we would ask to add the BC to the collection. And for all the BC instances. And only later we would ask for the insertion of the entire collection. Of course, here, if we want to get the messages of each insert, that of each item, we'll have to run through the collection and call the subroutine. And we should clear the BC collection before we start. If we try now with the empty table as before, it should give exactly the same result. Wouldn't it be simpler to do it using a data provider instead of loading the collection manually? That is to say, replace all this with an invocation to this data provider, which returns a collection of the office visit BC, loaded in the same way as in the web panel event, but at a higher level. Then, we load the collection variable with the result of the invocation to the data provider, to which we must pass all the parameters. Let's try it. Again, having cleared the table, we see that it gives exactly the same result. Of course, we can use the data provider to return a collection of business components as we did here, which we then assign to this collection variable, or to return a single one and do the insert on that one. For example, here we have this other data provider that will return a single BC. For this one, office visit. Note that collection is set to false, and only one header is loaded according to the values received in the parameters. Let's add a button that allows inserting a single office visit with the screen variables with those values. Then, we use the non-collection BC variable, office visit, that we already have declared, and load it with what's returned by this data provider, to which we pass the screen variables as parameters. The variable is indeed of the BC data type and not collection. Then we simply ask it to insert in the database and process the messages, adding the commit, of course. Let's try it. For example, for a date prior to this one, we insert successfully. Now, suppose that in case the record exists, we would like to update it. For example, we place the same primary key, but we want to change the office. Of course, a duplicate primary key error will occur, because we tried an insert and the record already existed. We can think then that to solve this, we can just modify the method that we're invoking, changing it to insert or update so that it first tries to insert, and if it fails due to a duplicate key, then it tries to update it. If we now try again to change the office of this doctor's visit to number 2, we see that indeed it did what we wanted. However, let's see what happens if we want to do the same, but this time, for example, for this office visit, for this day in the intermediate shift, and Dr. 1, who has another visit for the same day in another shift. Then we place that day, Dr. 1, shift 2, which is the intermediate shift, and we want to change the office from 1 to 2. Oops. Why did we get this error indicating that Dr. 1 already has 2 office visits assigned for that date? It's because the insert is tried first, and that's where this error is going to occur. Let's remember the order in which the checks are triggered. Before checking the uniqueness of the primary key, it'll first trigger the procedure that will calculate the number of shifts for that doctor. And if the result is 2 or more, the error rule will be triggered. What proves interesting here is that the uniqueness of the record will never be checked. Why? And there's something very important that should be known. Due to performance reasons, and assuming an optimistic strategy, in most cases, the insertion is not supposed to fail due to dupe PK. Therefore, all checks will take place first, and then the database insert command will be sent to the DBMS. This means that the insert is sent only when these previous checks were successful. And upon trying the insert, the DBMS may return the dupe key error. And only then will we know whether another record with that key already existed or not. So, if any of these previous checks fails, for example, due to this error rule, there's no attempt for the insert, and we cannot know either whether a record with that key already existed that would also cause the insertion to fail. In this case, the update is not attempted because it's only executed if the insert failed because of a duplicate key. If we translate the logic of the insert or update method to what happens in the background, it would be something like this. The insert is tried, and if it works, it continues with the code that comes after. If it doesn't work, only if it's caused by a duplicate primary key, the update is tried, which may or may not work, of course. But we have to bear in mind the behavior we just described. That is, if the insert fails due to something else prior to the actual attempt for insertion, since it's never known whether the record already existed, then it'll never execute the update. The reverse method has not yet been implemented in Genexus. But it should be analogous, in the sense that the insert should be tried only if the update cannot be done because the record does not exist, and not because of anything else. Since we don't have this method yet, we can try the update, and if it fails for whatever reason, try the insert anyway, knowing that if the failure was not because the key did not exist, then the insert will inevitably fail. Of course, we could also be more specific and try the load method and ask if it was successful or not, and then order an update or an insert respectively. If we want to be more efficient, we can search for the existence of the record with a find formula, for example. Let's try the solution. Now we were able to change the office. Let's go back to the batch insertion. Previously, we'd inserted all these records without any problems because there were no other records for that week in the database. But what if they existed? For example, let's suppose that these records already existed for that week when we want to launch the batch process. We'll want to do the same as in the previous individual case. That is, insert if there's no record with that key, and otherwise update. So, what should happen with each one? For the first one, there already exists a record with that primary key, this one. So, it'll try the update, which will work, changing the office for this one, number 1. For the second one, it checks if there's a record with that key, and since it doesn't exist, it tries the insert, but it'll fail because of a duplicate candidate key. The reason is that office 1 is already used. For the third one, it checks if there's a record with that key. It does not exist, so it tries the insert, which will be successful. For the fourth one, it tries the insert, which will count how many office visits are already entered for that day for the doctor, and since it will give 1, no error will be triggered, and it'll be possible to insert without any problem. For the fifth one, the same thing will happen. It'll insert without any problem. Now comes the sixth one, and since there's already a record with that key, it tries the update, which will be successful, modifying the office of the existing record. For the last one, since there's no record with that key, it'll try the insert, but will fail. Why? Because it'll find that Dr. 1 already has 2 office visits scheduled that day. How do we change the code we had to make it work like this? It's no longer useful to launch a massive operation on the collection of the 7 items returned by the data provider. We'll have to work individually, running through the entire collection, and in each case, checking for the existence of the record with that key. Here we must use the data of each BC. Or, if we want to do it a simpler way, we try the update, and if it doesn't work, we try the insert. Let's do so. Here we have the initial data, and now let's try to launch the schedule in batch mode for the following week, Dr. 1, Shift 1. Let's compare the messages generated with what we expected. The first one was updated successfully. Great. The second one failed due to duplicate candidate key. Good. The third one was successfully inserted. Good. The fourth one was successfully inserted. Good. The fifth one was also successfully inserted. Okay. The sixth one was successfully updated. Okay. And the last one failed because the doctor already had 2 office visits for that day. Great. Let's see that the office of this visit has indeed changed. Good. And this one, good too. So far, we've worked with 2 level BCs, but their second level was empty. What we're studying here in relation to the insert or update will have no difference with the case in which there's a patient collection that's not empty. Next, after addressing the differences between business component methods, we'll show how to perform the insert or update operations with a 2-level BC where we'll work with the lines. But we'll do it at the highest level using a data provider.